Alright, so let's do the same thing, and we'll say men's height and I say how tall is a man in the 95th percentile? Okay, so take a moment to answer that. Okay, we'll do this one also, just for fun. Okay, so we'll say recall on a box plot lower fence is equal to Q1 minus 1.5 times the exercise. Oh, no, okay, just do this problem and then I'll write a problem over here and you can solve it on your own at home for fun. You'll do that. So do this one, and then I'll just write the answer for this one. It doesn't matter which one you pick. 1.64 or 1.65. Okay, are we ready for this answer? Alright, so that's going to be 69.5 plus 1.64 times 3, so I get if you did 1.65, then 74.57, right? Alright. Is that okay? So knowing that we're in the 95th percentile, you find this z of 1.64 or 1.65, and then you multiply it by how many standard deviations, and that's how far you are away from the mean. Alright, you can try this problem out on your own, and you should get this. About 3/4 of 1% will be considered outliers. Okay, if we make a box plot for the normal distribution. So about 3 in 1,000. 3 in 1,000. I'm sorry, not 3 in 1,000. 7 in 1,000.
Can you just do that for us?
Just do it?
Yeah.
Okay. Alright. Okay, where's Q1 and where's Q3?
25% and at 75%.
Q1 is the 25th percentile, and Q3 is the 75th percentile. Okay, so I'm going to have 0.25 there and 0.25 here. What is my z-score? What is the z-score that's going to give me 0.25 there and 0.25 on the other side?
0.67?
Yeah, okay, so I got z is equal to negative 0.67 and z equal to positive 0.67. Alright, so based on this, what is my IQR? How many standard deviations is my IQR?
With
IQR is equal to Q3 minus Q1, right? So it doesn't matter that we've got positive or negative numbers. What's Q3? Q3 is equal to 0.67. Q1 is equal to negative 0.67. This is Q3 is I'm at 0.67 standard deviations with the mean. Q1 I'm 0.67 standard deviations below the mean. So my IQR is Q3 minus Q1, 1.34. That's my IQR. Alright. So, where is my upper and lower fence going to be? My upper fence is going to be Q3 plus 1.5 times the IQR. I'm going to go 0.67 plus 1.5 times 1.34. And what does that give me? And my lower fence, I do the same thing, but with Q1 minus 1.5 times the IQR. And I think I get 2.68, is that right?
Yeah.
2.68 and negative 2.68. Alright, so what percentage is beyond positive 2.68 and what percentage is beyond negative 2.68? When you look this up in the table, the area to the right beyond, so the area to the right is going to be 1 minus the value you look up for 2.68, and you get 0.0037. Is that right?
2737. 37, yeah.
37. And then negative 2.68 will also give me 0.0037. Okay, are you guys following me or no? Alright, so then the total area beyond my upper and lower fence will be 0.0074. So total area beyond the fence is equal to 0.0074. So about 7 and 1,000, 15 and 2,000 points-ish are considered outliers. So a little less than 1%. Okay? It's an arbitrary number, but that's what the people have decided will be an outlier. Okay? Everything is a little bit more nuanced than that, but we got to draw a line somewhere, right? A lot of things in life are completely arbitrary, but we've accepted them as such. Like, you have to be 18 to vote. Right?
Speed limit?
Speed limit, also an arbitrary number. Okay, I mean, there's some like reasonable, quote, reasonable number, but a hard line between, you know, must be born on this date and this year or after in order to buy cigarettes. You know, if you're one day too young, you can't buy it. So, it's not that suddenly on your 18th birthday you gain the wisdom to know your choices and consequences. Okay. Let's go back to what we learned last week about the binomial distribution. Okay, so in the binomial distribution we need, what do we need? What are the things that define a binomial distribution? Yeah.
Either success or failure.
Okay.
Binary outcome.
Binary outcome, okay. And what do we call the probability of success? We give it a letter. No? P, right? For sure. P is the probability of a success on a single trial. And how many trials do we do? N. N trials, okay. And we are looking for J successes. Alright, so let's say we are playing Casino Flip a Coin. It's the best game in the house. All right, and if the coin lands tails, you win. And so, what's the probability that you win when you play a game? 0.5. Great. And so, let's say we play 10 games, 10 flips. Okay. What is the probability of winning 7 or more times? See, this is what got me in trouble, right? No, I didn't actually get in trouble with it. Probability of winning 7 or more times. Okay. How do we calculate this?
The 7 into 10.
So the first one is going to be 10 to 7, 0.5 raised to the 7, yeah, times what?
0.5 raised to the 3.
Well, yeah, 1 minus 0.5, which is also 0.5 raised to the 3, okay? And because this is 0.5 and this is also 0.5, you can combine those two into 0.5 to the 10, okay? But I'm asking 7 or more, right? So I also have to do, what else?
8 and 9.
And 8 and 9.
Yeah, 10 choose 8, basically 0.5 to the 8, 0.5 to the 2, plus 10 choose 9, 0.5, all of these become 0.5 to the 10, and only for coin flips, and that's why I picked it for simplicity. And 10 choose 10, times 0.5 to the 10, right? I hope you guys don't get confused in your notes when you see 0.5 to the 10. This is 0.5 to the 9 times 1 minus 0.5 to the 1. And this is 0.5 to the 10 times 1 minus 0.5 to the 0. But because 1 minus 0.5 is equal to 0.5, I can add the exponents together. Alright, so what is this number? So let's see. 10 choose 7 plus 10 choose 8 plus 10 choose. Okay, I get 0.171875. That's what I'm getting. So this is the probability of winning 7 or more times in 10 games of casino coin flip. Basically, this is the probability of seeing 7 or more tails if I flip a coin 10 times.
So that's 17.18%?
Yeah. It happens about 17% of the time. If you flip a coin 10 times, you got a 17% chance of seeing 10 tails or more. Is there a question? Okay. Okay, what if I said, okay, well I want to play 30 games. I'm going to flip the coin 30 times. And I said, what's the probability I see, well, 70% heads again. So that means 21 heads or more coin flips. So I flip the coin 30 times. Okay, what is the probability of seeing basically 70% or more heads? Or I'm sorry, or more tails. Okay, so 70% would be how many tails? 21 tails, right? If I'm flipping the coin 30 times. Okay, so basically, what is the probability of seeing 21 tails or more? Okay, so if I want to answer this question, what would I have to do?
What we just did a lot.
What we just did, but it would be very painful. 30 choose 21, plus 30 choose 22, plus all the way up to 30 choose 30. Okay? And that sounds like it's not too much fun. Because it's not. Okay. So, what we can do is we can approximate this using the normal distribution. Because if you look at the binomial distribution, it ends up looking, because it's discrete, it looks like this. But it ends up looking very similar to the normal distribution. Okay? So we can approximate the binomial distribution using the normal distribution. So the binomial has n trials and p probability of success. The normal distribution has a mean and a standard deviation. What do you think we're going to use for the mean and the standard deviation for the normal distribution?
15. 1 over 2.
So the normal approximation to the binomial we're going to say the mean number that we expect is n times p. And what's the standard deviation of this normal distribution going to be? It's equal to the square root of n times p times 1 minus p. if I flip a coin 30 times, how many tails do I expect to see? 15, right? And that makes intuitive sense. And so that number goes right here in the middle. I'm expecting to see 15 tails. But I'm asking, what's the probability of seeing 21 or more tails? Okay. So I can, now that I have a mean and standard deviation, I can get a z-score and look it up in the normal table. Does that sound good? Sure. But here's the catch. Here's the catch. The binomial distribution is discrete, and the normal distribution is continuous. Okay? So we have to do something called the continuity correction. It's just a fancy word for saying we're trying to approximate a discrete thing using a continuous thing. Okay? So imagine, let's zoom in on this portion of the curve here. So imagine I've got a bar representing 15 coin flips, or 15 tails. Okay? Because I have one at 16, 17, 18, 19, 20, 21, 22, 23. Actually, this the line should go through the middle of these bars here. Okay. Now, so here I've got a bar centered at 21. Okay. If I want to include this entire bar, I would shade starting with the entire 21st bar, and then I would shade the bar for 22 and 23 all the way up to the bar for 30, which is going to be very, very small. Does that make sense? Okay, so when I draw my cutoff line, when I'm searching for the z-score, I'm not going to draw the cutoff line at 21. Or am I actually going to draw my cutoff line? So this bar, where is this bar centered?
20.
At 20, okay?
20.5.
So I would draw my cutoff line, not at 21, but 20.5. Can you guys see that? So here my z-score would be 20.5 minus the mean, which is 15, and the standard deviation, which is n times p times 1 minus p. So what is that? Square root of 7.5, 2.739. Okay, so I'm getting a z-score of 2.01. That's my z-score. Does that work for you guys? Okay, so now that I've got a z-score, I can look that up in the table, and I can see what the probability, if I flip a coin 30 times, what's the probability of seeing 70% or more tails? Well, that probability is, when I look up 2.01, I'm looking for the area beyond that, 0.0222. So this area, 21 or greater, 0.0222. So what is the probability of seeing 70% or more tails, or seeing 21 tails or more? About 2%, 0.0222, a little bit more than 2%. Yes? How do I get the standard deviation? This n times p times 1 minus p?
So use
So my n is what? What is my n? My n is 30, and my p is 0.5. So I'm doing 30 times 0.5 times 1 minus 0.5.
why is it 0.5
Oh, because that's the probability of a success for a single trial.
for a tail? Or
Yeah, of getting tails on a single
so
coin.
you're not using that 70%.
Right.
Okay.
The 70% is how many successes I'm looking for.
Okay.
Okay? How do we feel about this? Let's try an example. So I'll give you guys a problem, and then I'm going to use the computer. Okay. So let's say 11% of the world, or let's say 11% of the US has type B blood. Okay. We select 100 random people. Okay, and I ask, what is the probability I find 10 or more people with type B blood? Okay, so you guys go ahead and try that out. do we get an answer? Yeah? No? More moments? No. Maybe I might have messed up. I just did it right now. Okay. Alright, so the real way to answer this would be to do 100 choose 10, plus 100 choose 11, plus 100 choose 12, all the way up to 100 choose 100, right? But we don't want to do that. If I make a normal distribution to approximate this binomial distribution, what is the mean going to be? The mean is equal to,
N times P.
yeah, so how many, if I pick 100 random people, how many people do I expect to have type B blood? 11. So I do N times P. I'm expecting 11 people to have type B blood. What's my standard deviation going to
11.49.
be? What's that?
N times P times
Yeah,
1
100
minus
times P, which is 0.11, times 1 minus P.
1.
And, I think I did this correctly.
3.12.
So, square root of 9.79. I get 3.13, pretty much, okay? Maybe I'm keeping a few more decimals in my calculator here. Okay, and I'm asking for finding 10 or more people with type B blood. So, if I draw this, I have a bar centered at 11, and then I have a bar centered at 10, and I want 10 or more. So, which direction am I shading? Am I shading to the right or to the left?
To the right.
To the right, okay. And do I include the bar for 10 or not include the bar for 10? I include the entire bar for 10, and everything over here, and everything over there. So where am I drawing my cutoff line? 9.5. Okay. So I'm drawing my cutoff line at 9.5. So my z-score, what is my z-score going to be? 9.5 minus 11, which is my mean, divided by 3.13 or 3.1288 or whatever number you have. So I have a z-score of negative 0.48. Is that good? Okay, so now I want to know how much is to the right of z equals negative 0.48. So there's a couple ways I can answer this. I could look up z equals negative 0.48, and the value that I get is 0.3156. Which is the area to the left of negative 0.48. And then I do 1 minus that, and I get 0.6844. Or, I can go to the z table, and instead of looking up negative 0.48, I can just look up positive 0.48. Because the area to the right of negative 0.48 is going to be the area to the left of positive 0.48. And so when I do that, I get 0.6844. So what's the probability that I find 10 or more people with type B blood? 0.6844. Is that okay? Okay, great. Let's take a look at the computer.